Do we also have a class at 8:30 today?
Sorry?
Will we also have a class at 8:30 today?
Yeah, inshallah, we'll have the regular class as well after this class, right? Okay.
Okay.
Now we are on the pressure and we're gonna talk about how does the density of a liquid affect the pressure? How does the density of a liquid affect the pressure it exerts? Mm. So if we have if the two fish are kept in the two different uh, containers having different containers having having different type of water. One one contains one contains the seawater and one contains the tap water, right? Okay.
Yeah.
So what we know that a different, different, different liquid will have a different densities, right? And density depends on mass and volume, right? The density depends on mass and volume, right? So what will happen on this, for the same volume, the weight of the seawater is greater than the weight of the tap water. So one fish the having a seawater, uh, that fish is going to experience a greater pressure. Okay.
Okay.
So mm, for the same volume, the weight of seawater is greater than the weight of tap water, right? So
Yeah.
the fish which is in the sea water will experience will experience a greater uh, pressure, okay, compared to the other fish. Clear? So the thing is that what we have developed, the concept that we have developed here is that the pressure in liquid affects gets affected by the density of the liquid. Okay. And we can
Okay.
conclude here, what we can conclude here, that pressure Pressure in a liquid increases with depth and density, right?
Yeah.
Now, which formula will work for the density of the liquid? If I have a container, if I have one container and the cross section of this container is A, clear? And the height is H, clear?
Yeah.
Right? Now, by the concept of pressure, what we know is pressure is what? Force, force
Over
applied over unit
area.
area. Force applied per unit area, right? Now, if I change the force, what will happen? The pressure will also be changed, right? Keeping the area same. Clear? This delta sign shows this delta means change. Okay, clear?
Okay.
Delta means the change. So change of force, or if you change the force, so the pressure will also be changed. Clear? Now, if I replace the force by the weight, can I replace the force by the weight? Yeah, force is actually, weight is actually a force, right? So what I can do
Yeah.
here, I can also replace, the W with mg. What is mg? Mass times strength of gravity. Mass times
Yeah.
the strength of gravity. Clear?
Yeah.
Now, if I recall the formula for density, what is the formula of density? Density is,
Density equals mass over volume.
yes, mass over volume, right? Now, if I make mass subject, so I have to shift this volume to the density side. So it will become volume times density equals to mass. Clear? Clear?
Yeah.
So can I replace mass with the values volume and density? Can I place volume and density here?
Yeah.
Okay. And keeping area here, right?
So volume times density equals mass.
Yeah, this is what I have done here. So what I can do here, that pressure is going to be density and volume of the liquid divided by the area. Now, if I ask you to find out the volume, whatever the the substance is there inside this container, so the volume is going to be cross section area, cross section area of cross section times the height, right? Yeah.
Yeah.
So what I can say here, area times height will be volume. Yeah. Now, can I plug the value of volume over here?
Yeah.
That's going to be area times and change of height times density times strength of gravity divided by area. So, do you agree that this area and this area gets cancelled?
Yeah. But why can't we just do force over area?
Okay, so actually we are trying to make a relation between the pressure of the liquid with the density, okay? Density
Okay.
and height. Now,
Okay.
what have we got here? Are we getting this? That we have
Yeah.
just discussed that the pressure of the liquid, is directly affected by the density of the liquid and the height. Okay, the height covered from the surface of the liquid. Is this clear now?
Yeah. Can you just give me 2 minutes? I'll just use the washroom.
Yeah, you sure you can. So now we are going to talk about the change of state, right? And we will be able to describe the arrangement and motion of particles in solid, liquid, and gases, right? And how the heat, change the energy stored within the system and raises its temperature or produce change of state.
Okay.
All right. Okay. So we're gonna talk about the change in state.
The solid, liquid, and gases.
Yes.
So this is
Change.
the last unit,
Yes.
and then we'll start with the past papers.
Yeah, we will be inshallah starting the past papers. Okay. All right. So change in state. Um, what are the properties of the three state of matter? We know that there are the three states of the matter, that the solid, liquid, and gas. Okay.
Yeah.
So matter has mainly three states that we consider. Mainly there are three states: solids, liquid, and gases, right? So what we know that water in the liquid state is actually found in the in the free shape. It does not have a fixed shape, okay? And whereas the solid has a fixed shape and the fixed volume, right? So liquid has a fixed volume but no fixed shape and a high density, and they are incompressible. So liquid, what about the liquid? They have the fixed shape. Sorry, I'm
No.
sorry. Fixed volume, right? Fixed volume
Yeah.
and no fixed shape, no fixed shape. And the third thing that compared to the density of gas, liquid has a high density, okay?
Okay.
High density than gases. Okay. And uh, we should know that uh, that liquid cannot be compressed, right? So incompressible, incompressible. And why are we saying incompressible? Because when we say that compressible, so that means that can decrease in size. Okay. Compressible means
Can
incompressible. Okay, let
decrease.
me let me say in terms of incompressible means that incompressible cannot decrease in size. The thing that
Okay.
cannot, the thing that cannot decrease in size. Clear?
Yeah.
Right? Uh, if you talk about solids, so in solids, what we know that solids have fixed shape, right? And fixed volume, right? And compared to the density with the liquid and gas, it has a high density. Okay, and cannot flow, right? Solids cannot flow. Similarly, if we talk about gases, so you know that the gases do not have the fixed shape or volume. Clear? No fixed shape or volume. This is a very common, information that everyone, most of the students know. Low density, right? And they are compressible. If I am saying it is compressible, that means it can change, it can decrease in
In
size,
size.
right? Okay. And can flow. Yes,
Yeah.
gases can flow and take the shape and volume of the container, right?
Yeah.
Now, if we say that, how does the matter, state of the matter changes from one state to another, right? So there's a process, and process means that we no new substance form. Okay, clear? For example, if I have the ice, right? If I have ice, and it goes to the water. So the process that takes place is the name of the process is known as melting, right? Now, if I say that water is coming back to the ice, so that's going to be freezing, right? So these all processes you people have already studied. And if the water is, if I have the container here, and the water inside that. So if I have the water and then it is going down, going out, coming out, right? So it is converted into gas. So this process is going to be boiling, right? This process is going to be boiling. Either you can call it boiling or you can call it evaporation, right?
Yeah.
So evaporation, remember, it um, always takes place um, at the surface of surface of liquid, right? Clear?
Yeah.
And if I say there's a conversion of the gas to liquid, so which process that takes place?
Solid to liquid
It's
melting.
it's no gas to liquid. I'm saying
Um,
con
condensation.
it's condensation, right?
Yeah.
Clear?
Yeah.
Now in our syllabus, they demand to know about the particles arrangement and movement in each state of the matter. Clear? So we're gonna talk
Liquid.
about that, the particles arrangement, particles arrangement and movement. So what we know um about solids, if we talk about solids, so how the particles are arranged. Particles are closely packed, right, together. and they are usually they are usually in a regular pattern, right?
Yeah.
Randomly arranged, okay? And what we know about the solids is a large number of particles per unit volume. That means the density is high. And the particles, since the particles of solid have least energy, so they can only vibrate, right?
Yeah.
Yeah. They can only vibrate about a fixed position, right? Yeah.
Yeah. Yeah.
So what happen if we supply the heat to to the solid substance?
It can melt.
Okay. So when the object is heated, when the solid object is heated, so what happens? The internal energy,
It increases.
yeah, internal energy increases. Okay. Thus the
The
temperature,
particles vibrate more.
yeah, the temperature, exactly. The temperature of the solid object, the temperature of the object increases, right? This means
Yeah.
this means the average kinetic energy, the average kinetic energy increases, right? Okay.
Yeah.
Yeah. Now, if I talk about the liquids, if I talk about the liquids, so in liquids, the particles are slightly
Moving freely.
further apart.
Yeah.
So particles are slightly further apart than in solids, right?
Yeah.
Okay. And they are randomly arranged. Yeah, they are
Randomly arranged.
randomly arranged, right? And have the smaller number of particles, have
Yeah.
smaller number of particles per unit volume. And how do they move? Are they free to move? Yeah.
Yeah.
So this means that the liquid particles are free to move within the liquid, right?
Yeah.
Now, what if I heat the liquid particles? So what will happen?
They'll heat up. They'll start boiling.
Yeah, exactly. So when No, that first of all, we will talk about the temperature rises, okay? Clear?
Okay.
When the liquid substance is heated, they start they start vibrating faster, vibrating faster. The energy of particles increases, right?
Yeah. So whenever something is heated, the particles vibrate faster.
Yeah, actually they vibrate in that region faster. That means the collision becomes frequent. The
Okay.
the energy of particles increases, right? Uh, thus the temperature also increases. Clear? The spaces, right? The
Yeah.
spaces the spaces between the liquid particles increases, right? And what happens? The force of attraction, the force of attraction becomes weaker. Clear? The force of attraction between the particles of liquid. Now we talk about the gases. What happens with the gases? How the particles are arranged? Since we know that particles are far apart, right?
Yeah.
Gas particles are far apart from one another. Okay. And they are also considered as randomly arranged. Okay. And have small number of particles per unit volume. And the particles, the gas particles move randomly at high speeds, right?
Yeah.
Okay. So they have the greatest energy. Remember this thing. Greatest energy than solid and liquid particles.
Okay. Just give me 2 minutes to write this.
I'll share the okay because the class is going to end. That's why I'm doing it faster so that you can, later you can complete it. I'll share the file.
Okay.
So since that they have the highest energy, so they move with a high speed, right? So remember this thing that the gas can flow and fill the space, right? They are put into it. Okay, whenever they are put into the container, so they fill the space. Why? Because they are at the high speed. Clear? So what happens when
Okay.
when um when the when the heat is given to the gas particles? What will happen? They collide.
They'll start vibrating faster.
Okay, they collide faster. They collide faster. Clear?
Yeah.
They collide faster. The energy increases. The energy of particles increases, this causes rise in temperature. Is this clear now?
Yeah.
So now I want to know that what is temperature. I have already talked about the temperature in the last couple of classes. Temperature is the average kinetic energy of particles. So we will end our class here, and I think only one session will be required to complete the rest of the things. Okay, some investigations are left. Inshallah, we'll be able to cover it.
Okay, inshallah.
You will be joining the class again after 9 minutes, right?
9 minutes or 8:30?